Tes 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 1 2 3. Tes 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 1 2 3. Tes 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 tes. Oke. Hmm. Ya lebih kali yang mencari Eureka namaku Lupus Magusteen dari channel Kota channel dari Masa. Hmm. Untuk sekarang catatan. Aku lagi pikiran pengen bikin game-game side scrolling ala-ala Grand Guys. Cuman nggak tahu ini tutorial YouTube yang mana yang bagus yang bakal aku ikuti. Platformer. Definisinya apa ya? Side scrolling sama platformer. Na 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 na. Turururururu, turururu. Side scrolling dan platformer itu bedanya apa? Game dan case Sesi itu termasuk side scrolling adalah istilah yang merujuk ke kamera bergerak dalam game. Biasanya layar bergeser ke samping mengikuti karakter, seperti Mario Bros. Platformer itu menunjuk ke genre gameplay. Platformer itu punya ciri khas kayak lompat dari platform pertama ke platform yang lain. Platformer itu nggak selalu side scrolling 2D, bahkan juga ada yang 3D, kayak Crash Bandicoot. Oh, paham paham. Kalau Grand Guest tuh lebih ke side scrolling action RPG. Bukan platformer murni, tapi ada juga yang sampai jatuh-jatuhnya juga. Tapi lebih ke fokus di combat skill dan dungeon crawling. Hmm, kalau aku pengen bikin kayak Grand Guest side scrolling dengan aset gambar PNG itu ah, anjing gamenya kamu saranin apa? Cuma Unity doang ya? Bisa pakai PNG langsung, lisensi berbayar. Maksudnya berbayar kah? Kalau ke Asisora, thank you for coming. Kurang fleksibel untuk 3D. Type and mudah untuk pemula. Game Maker Studio atau Constructica. Yang gratis. 'Hmm, mhm mhm. Godot ya? 20 second, what? Why makes 2D? Hmm, bentar. Oke, makasih sudah mampir-mampir. Selamat menjalankan ibadah puasa. Tapi kayaknya Godot ini terlalu pixelate ya. Godot terlalu pixel. Hmm. Default itu apa? Default. Nurut tururururu. Tururut turururururururururut. Mhm. Mmm, aku masih bingung milih yang mana. Oh, drag and drop ya? Oke, kalau gitu yang Godot aja. Mhm. Di Grand Case itu mhm, side scrolling yang ada kombonya, serangannya, ada filtry. Mhm. Action RPG 2D. tutorial Godot rolling RPG 2D. Let's scrolling movement, combo system, file system, sprite, yes, UI, multi. Saran pencarian tutorial. Kembali cipi-cipi ya kebanyakan. Oke, sekarang aku juga pengen tahu caranya install Godot. Tulisannya live chat, live chat, live chat. Na 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 na. Tutorial install Godot.
Kali ini kita akan menginstal Godot. Untuk menginstalnya di Windows, tolong hiraukan wallpaper gua. Kita buka browser, terus kita cari Godot. Kita pilih link yang pertama dari godotengine.org, kemudian kita pilih download latest, dan kita pilih download engine. Nah, tinggal tunggu deh sampai selesai. Kalau sudah, kita ekstrak pakai 7-zip atau WinRAR. Yang gue paling suka dari Godot adalah dia nggak perlu diinstal. Pas diekstrak, programnya langsung bisa dijalankan. Tinggal klik 2 kali executable-nya dan langsung terbuka. Jadi seluruh programnya ada di satu file executable ini. Supaya nanti gampang diakses tiap hari, kita bisa klik kanan terus send to desktop. Nanti shortcutnya akan terbuat di desktop.
Enak
Kita
banget
bisa
ya.
ganti nama ke Godot. Tinggal sebentar ya. Tinggal klik 2 kali dan langsung terbuka Godotnya. Kita tinggal create new project, terus kita kasih nama project kita. Gue kasih nama project gue Petapa, nama game yang akan gue buat. Nah, tinggal create deh. Kalau sudah sampai sini, berarti sudah berhasil. Untuk Mac dan juga Linux, cara installnya juga sama. Kita tinggal ke websitenya, download latest dan download engine, tunggu sampai selesai, nanti tinggal ekstrak dan jalankan. Dari
Cepet banget, tinggal berani atau enggaknya. Durum. Kita install dulu Godot. Godot free open source. Download latest 4.6.1. Ini klik download yang mana? Durung durung dum dum. Ini nampak semua. Coding pakai C+, Kalender C+, pengguna biasa. Aku nggak bisa coding. Ini mau ini baru mau belajar. Aku pilih produk ini. Ini pilih yang mana? Yang standar. Berarti jangan bisa dimakan untuk yang oke. Download. Root exists to thanks to donation from people like you. Help us continue our work. Make donation. Unduhan program folder baru Godot. Simpan. Oh, cuma 76 MB. Kecil ya. Durum durum durum. Also available on digital distribution platform. Steam or udah ada di Steam ternyata. Ya, aku unduh dari Steam pakai Godot. Oh, ini ada. Dum 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 dum. Pesan dalam bahasa Indonesia mengecewakan. Waduh. If you wanna code a bit, Godot script, go for it. But if you wanna use C+, have to download another version from their website, not this version. I'm gonna keep using this, but it crashes a lot. I cannot download the version. Oops. Sensmed. Engine feel like they are made it rush. Now how far you have fallen, you must first hit rock bottom. Growth is still failing. Let's get Unity. They call them another good game made with this engine. No reason to use above enter engine. Total tutorial available on YouTube. Kok ulasannya jelek-jelek ya? Maya, Maya, Maya. Kita download aja nggak sih? Korot, disuka nama-nami alright. Biasa sikaran ut Giga. Oke. Oh beda. Oh iya. Cara dulunya oke, udah oke lah. Sekarang tutorialnya dulu. Kita nonton tutorial. Na 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 na. 48 detik. Let's scroller basic.
Hello everybody, Chris here, and in this video I want to give you guys a quick getting started guide for Godot 4.0.1 in the essentials of getting set up with a platformer character that can move around on a tile map. So for this tutorial I'm going to be using this free asset pack by Anokalisa at anokalisa.itch.io, and I'll put this link in the description so you can pick it up too. And I'll also be posting a link which will have the full project at the end of the video, freely available for download as well. So if you haven't already, make sure that you're working with at least Godot version 4.0. It's a major change from the 3 series, of course, so some of the scripting is not going to be the same as it was previously, so just make sure you're on 4.0 or above, which you can get on godotengine.org. So inside of Godot, we can create a new project, which I'm going to do by clicking New Project over here.
Alhamdulillah, kecepatan ngomongnya aku masih bisa sih. Oh, ini tampilannya Godot ya. Oh, ada. Ini mungkin nggak ada. New project.
Here on the right side. And in this project, we're going to go ahead and use the mobile renderer so that we have maximum support for desktop and mobile platforms. We really have no need for any of the advanced features since we are doing a pixel art game, which is as graphically simple as you can get, really. So let's go ahead and put our project somewhere on our computer. So here I have a path dedicated to Godot tutorials. I'll go ahead and select the current folder. As you can see, it'll say the selected path isn't empty, so we'll want to create a folder with the project name inside of that directory. So I'll call this one Side Scroller Quick Start, and let's create the folder and create an edit. Okay, so in our new Godot project, we have the file system in the bottom left. We can create nodes, which are going to include our root scene and all of the characters and tile maps inside of our scene hierarchy over here. And here we have the viewport window. You can see it's in 3D right now. Obviously, we want to change that to 2D for our pixel art game. So let's change to 2D up here, and you'll see the view is completely different. And now what we need to do is import all of the art assets into the project. So I'm going to click on the resources folder down here and choose open in file manager. So here's basically the root of our project. We can drag in any art assets we need from our computer. So I'll minimize some of the windows. And here we have the Legacy Fantasy High Forest pack that I mentioned at the beginning of the video. I'm going to drag this into a new directory. I'm going to call art. So inside Scroller Quick Start, I'm going to right click new folder, and I'm going to call it art. Let's hit enter to create it, and then double click into it. And I'm just going to drag this Legacy Fantasy pack into here. So in Godot now, we can expand resources and art to see all of the assets we just brought into here, including the character with its animations. And then in assets, I believe we have our tiles for building out the tile.
PNG. Okay.
So let's create a new 2D scene for our level. In the scene window at the top left, click on 2D scene. I'm going to rename this to be test level. Let's hit enter, and I'll Control S to save the scene into a new folder in the project. So I'll hit create folder, and I'll call this folder levels. So inside of here, just test level.tscn. Let's hit save. And there we have our completely blank level. So that we can actually see something on our level, let's create a tile map and start drawing some tiles onto the screen. So I'll right click on test level, and let's add a child node. I'm going to search for tile map, and it should pop up under node 2D. So let's create this node into our scene. You'll see at the bottom window, we have this tile map panel, which pops up. And so we'll need to drag in some tile assets into here so that we can use them. So next in the inspector with tile map selected, let's take tile set, and I'll click on the drop down window and choose new tile set. So when we do that, we can see a little grid appears over here. Okay, so now let's take some of the tiles and put them in this tiles window. So let's drag tiles.png into here, and you'll see a whole bunch of stuff appears over here on the right. We'll have this atlas's texture was modified. Do you want to create tiles in the atlas automatically? Let's go ahead and say yes to that. So now you can see that in our image, wherever there was graphical information, a 16 by 16 tile has been created automatically. So that's super handy for us. And we can use these on the tile map panel in order to draw. So before we start drawing with any of these tiles, we'll want to set up a collision shape so that we can't just simply have our character fall through the ground later on. So in order to do that, let's expand tile set inside of the tile map inspector on the right. So if we click over here, we can expand that, and you'll see physics layers is an option here. So we want to go to physics layers, add an element. So when we create our physics layer, by default, it's going to interact with other objects, which are handling physics on collision layer 1, which is the default. We don't need to get more complicated than that, so just leave one for layer and one for mask checked. And let's also go down here to where we have layers. So for our layers, we could call this ground or walls, if that makes more sense to you. So these are going to be the tiles which our character stands on and can collide with.
Oh ini ya, kayak mendefinisi.
Layers, we could call this ground or walls, if that makes more sense to you. So these are going to be the tiles which our character stands on and can collide with. So ground or walls, whatever makes sense to you. Okay, now let's click over on our tiles using the select option. Click on a tile, and physics should be available to us because we created a physics layer. So expand physics layer 0, and we'll come down here to where we can define the physics shape for the tile. So the easiest way is just to click here and do reset to default tile shape. When you do that, it's going to take the 16 by 16 square, and then it's just going to draw the same size box around it for the physics shape. So obviously you can use these other tools, like the edit points tools, to make the collision shape different. But for right now, it's just going to be much faster and convenient if we take the tiles we want to collide, and we just click on each one and either do here to reset to default tile shape, or you can just click on each one and press F. So if we do F, F, click, F, click, F, click, so on and so forth.
Like really,
we're going to set up
untuk semua
for these tiles very easily. And you can edit it and fine tune it later on if you need to. So for these top tiles, I'm actually not going to add a collision there because I think the idea is we want our character to stand somewhere halfway between this grass.
Yeah.
So we don't want the top bit to cause our character to collide because then it would be standing on top of the tile. So these tiles up here don't have that collision shape, but these ones down here definitely do. For more complicated tiles like these angled slopes, that might be a case where you'd actually want to draw a physics shape at an angle. We're not going to worry about that for this video since we're just doing a quick start. So let's take these tiles and draw them onto our tile map. So go to the tile
Bisa
map
di copy
window,
paste ya.
and then you can click on each of
Atau
these tiles
ditarik gitu
and then
seret.
draw them onto the tile map. So
Hah?
make sure you have tile map selected so that you can actually see these tiles popping up. And if you want, you can
Satu.
select a whole bunch of tiles with the left mouse and hold.
Oke, bisa di hold.
Select them all, and you can actually draw all of them at the same time. So if we come down here, somewhere like there, and just click a few times, then we'll get some ground added. For these in-betweens, I'm just going to select the middle tiles. So select these, go up here, and then left-click and kind of fill in
Terus?
our tiles. If you also want to repeat a pattern, you can find the point where you want it to start, left-click, hold, and then drag all the way across your tiles. If you also want to repeat a pattern, then you can use the line tool over here. Find a point where you want to start, left-click, hold, and drag it to where you want it to end, let go, and it will repeat the pattern across all of those tiles. So we can click here, left-click, and drag it all the way over here, and that would fill all of that in as well. So I might want so if this is the edge of our map, I still might actually want it to go further to the left. So let's drag that out a bit more. And when we add a camera and a character, we'd probably be able to actually see below this ground right now. So I'm going to take these 3 tiles and let's fill in a big box actually below all of this. So I'll select here, tool. So let's use the rectangular box tool, or R on the keyboard. Select here, and then just drag a box down here. So making our wall ground tiles a lot bigger. And then we can continue with our bottom rock pattern at the bottom down here. So I'll left click and just keep going along the lines here, roughly something like that. Let's get the wall tiles over here, the corner tile, and over on the left, let's do corner tile, the wall pattern, and I guess at the top we also need the corners up here. So let's fill that in with these 2 squares. Over on the right side, select these 2 for right there. And then we need the repeating grass tiles to go on top of everything else. So let's drag that from left to right, kind of like that. And there we basically have a simple platform where we can stand on. And if I set up the tiles correctly, then the physics layers should work as well. One way you can check is going up to, let's see, debug, and then do visible collision shapes. Okay, so we could test how this would look now by playing the current scene, which you can do at the top right, F6 on the keyboard, play current scene. And we should see at least part of the tile map grid show up here. So basically, by default, it's going to show from the top left 0, 0, and then going down and to the right. So anything to the left here, we wouldn't be able to see. But you can also see, of course, that everything is really small scale. For pixel art, this would be way too much stuff on the screen if we have like microscopic sized creatures around here. So what you're going to want to do is change the window settings for your project. So go up to project settings, go to window, and let's change the scale down here from 1 to 4. I think 4 is usually good. Then we can hit close. Let's play the scene one more time, and it's going to look a lot bigger. But now that we're so zoomed in, you can also see that it looks kind of blurry compared to the original art. So there's another setting we want to change for that. If we go to project settings, and then we go to renderer, I believe, or textures actually. Then for canvas textures, you want to change the default texture filter from linear to nearest. Now when we hit play or start the scene again, you'll see that the pixel art renders much clearer, and that's basically how you get pixel art to show correctly in a 2D game. So now when we hit play again, you can see the pixel art renders properly, and that's basically all you need to do to get pixel art to look correct in your 2D Godot game, which is very convenient. Okay, so the next thing we're going to do is create our character. So on test level here, let's right click, add a child node, and we're going to search for character body 2D, which as you can see here is a node when you want to create a character that can move around on the screen. This is
Bisa
usually gonna
campuran
be
3D
what you want.
juga ya.
So let's create the character body 2D. we'll get a little warning here, which will say that you need a collision shape for a character to work properly. So the character body handles the physics, but it's going to rely on a physics shape in order to be able to calculate anything. So let's right click on our character body 2D and add a child node to it. We're going to search for collision shape 2D. So double click on that. For shape over here in the inspector, let's click on a new, we'll go with capsule shape. And then you'll see our collision shape pops up here on the screen. We have no sprite to really reference for how big this shape should be yet, so we'll need to fix that in a second. For right now, let's go to the character body 2D. I'm going to rename it with F2, and let's call it player. Now let's right click on player and do save branch as scene. So we'll save this. If you're used to Unity, this would be like a prefab, but really it's just a scene stored in your assets project, which you can reference in other scenes wherever you need to instantiate a copy of it in a sense. So let's create a folder for characters, and then we're going to create our player scene inside of here. So for character folder, player.tscn, tscn is for a Godot scene. Let's hit save. Okay, so now if you need to add this character to any other scene, you can just drag and drop it into the scene. So like so, you can just create copies of whatever character or object you need in your game. Let's jump into the scene editor for our player. So when you have a scene saved, you can edit it inside of its own scene. So open an editor. Now we're opening and editing player.tscn. So we're no longer in test level. This is its own separate scene. So you can see the hierarchy as scenes inside of scenes, and those scenes will contain nodes. So let's take our player and add its character sprite to it. So I'm going to expand art and legacy fantasy. Let's go into character. I'm going to find idle. So let's just drag this idle sheet onto the screen, and then that will create a new sprite 2D node for us to render our character. Now, of course, we don't want all of these frames at once. So let's go to animation here, and we'll set the number of horizontal frames to 4. So now we're in frame 0, which is the first one. So if we wanted to change the frame, we would just increment this by 1. And you can see how you can cycle through the different frames of our idle animation. So let's rename idle sheet to be sprite, since we're actually going to change out the texture when we change our animations. And now go to the transform of our sprite and change the position to 0 for X and Y. So we center it up here. Now I'm also going to move the collision shape below sprite so that it shows on top of the sprite, easier to edit. And then click on collision shape 2D so we can see the inspector, go to the shape, and let's increase the height of our capsule shape. I'm actually just going to type in some numbers like 40 until it matches our character to a reasonable amount. So we might set the height to 45 and then just move it down a little bit. So you can take the transform of the collision shape and add a few pixels to the Y. So 2 on the Y pixel means that the hair won't be a collision shape, which is actually probably what you want. It would be a little cheap if an arrow went over the head, but still connected and hit the player. So let's just be nice there. And the important thing, if we zoom in, is that our bottom of the collision shape roughly is where the feet touch the ground. So I might take the height here and shrink it a little bit. So 44.5 or maybe even 44. Yeah, I guess 44 is exactly what we want here. So we can see the bottom of the collision shape matches the exact bottom of the ground. We can also decrease the radius if we think this is a little too wide. So maybe something like 8 would be a little bit better. And that should be reasonably okay. So if we go to our test level, we can see that the player is now somewhere inside of the scene. Let's take the player here and move it onto the ground, roughly where we want the player to start. Okay, actually, let's move it a little bit above the ground. And then I'm going to hit run current scene, and you won't see the player move yet. So even though there's a character body and a physics shape, the collision shape 2D, there's no physics actually being added to the player yet. So the quickest way to get that to work is to use the template script for Godot on character body 2D. So let's jump into the scene editor for player, and on a player node, which is really the character body 2D, go down to script and do new script and use the template. So check template right here, and then do character body 2D basic movement. For the script name, we can just leave the default down here, player.gd, matching the node name of the player. And this will save in the character folder where our scene is also stored by default. Up to you if you want to organize your scripts like that. Another option would be to create a scripts folder and save all your scripts in there. And this will save here player.gd, matching the node name of the player. And this will save in the character folder where our scene is also stored by default. Up to you if you want to organize your scripts like that. Another option would be to create a scripts folder and save all your scripts in there. But this might be easier to understand, and where you have a character saved to your project, you have everything associated with that character in basically the same spot. So let's hit create, and then you're going to see in the script editor for GD script, the defaults for our character script. So if we go back to test level and we hit play current scene, then we should see our player falls to the ground where we set up the physics shape. So remember, these top tiles, the grass on top doesn't have a collision shape, so this is actually where our player is meant to stand in this art pack. So that's pretty handy. And also we can press left and right to move our character. I believe space is jump by default. So already you kind of have a lot of the basics for your character setup out of the box, which is pretty handy. Now, there are definitely some things we want to improve about our character script rather than just using this and going. First off, our constant speed and jump velocity, as things are right now, if you click on the player node, you can see that that's not editable inside of the inspector. So we can fix that pretty easily by changing our constant into a export variable. So I'm going to take constant right here, and I'm going to change it to @export var speed, and I'm going to put a colon after it, specify float as the type of variable it's supposed to be. Not required, but this is like a helpful hint indicator saying that the speed variable should be a float. And if we save our script, we can see over here on the right, player.gd has the editable variable speed, so we can change the value here if we want it to differ from what's hard-coded inside of the script, which is a handy thing to do. Next, because it's no longer constant.
Oh ya. Kalau misalkan kita nggak pakai export var speed gini, nggak bakal muncul di filter propertinya. Cuman kalau udah muncul di filter properti, ntar kalau misalkan pengen ganti speednya tinggal di bagian sininya gitu kan, maksudnya biar lebih gampang. Wow, makasih loh.
I'm going to select this text right here. You can double click on it and then hit Control R to do a find and replace. And let's change it to just speed lowercase. Replace all so that any instance of it in this script document gets replaced and updated so the script still compiles and works. And let's do the same thing with the jump velocity. So I'm going to remove constant, change it to export var. Don't forget the @ because this is Godot 4. And I'm going to do colon after that and specify it as a float. I'm going to select the text, Control R to find and replace, and let's do jump underscore velocity all lowercase, and then replace all. Okay, and you can see both of those variables over here on the right. We can customize the value to whatever we want for our character. Now, we can also change what the defaults should be. And I'm going to go with, let's say, 200 for the speed. And I believe that's measured in pixels per second or something. And then jump velocity, I'm going to change to -200. -200 for Y values means it's going up on the screen. So down is actually a positive value for Godot 2D, and up is a negative value. So if we take those values and run the scene again, and do left right, we'll see that our character moves a little slower. If we hit space, then the gravity is pretty harsh on our character. I don't want the character to jump super high, but I also don't want the gravity to pull it down to the ground so fast. So we don't have to have realistic physics for our side scroller, and most side scrollers would not, actually. So let's just stop the project for a second and go to project settings. For filter settings here, just search for gravity, and then under physics 2D, we can change the default gravity. I'm going to change that to 490, so that our character is a lot more floaty in the air. So let's hit close. So let's actually take a second and set the default scene for our project. So when we hit the normal play button, play the project, you'll see that no main scene has been defined. So we want that to be the test level. I guess we could say select current since we're on the test level right now, but let's manually select it. Go to levels and then test level.tscn. So now when you hit play, it'll automatically start with this as the default. Okay, so now let's move our character around. We can hit space and we can see that our jump is a lot more floaty than it was before. Maybe our character jumps a little too high. So if you want, you can change the jump velocity either in the script or over here to something like -150. I'll change it over in the script so that the default's consistent when you guys download the project. And let's hit play. I'll hit space. And then we have our kind of floaty jump and a decent amount of jumping into the air for our character. Okay, so another thing we want to fix, if you actually look down here, is that it'll say that we're using the UI actions by
That input, direct, and handle movement declaration. As good practice, you should replace UI action with custom gameplay action.
default for moving the character, but it's a good idea to create custom gameplay actions. So add in some keys that do a custom action when you want to move the character rather than using the UI default actions. So go to project and project settings, click on input map, and you can show the built-in actions by clicking over here. So these are all the built-in defaults. Boy, that's actually a lot. So
Yeah,
let's
that's a
hide those
lot.
for a second, and let's create our custom actions meant only for our character. I'm going to type in up here, and let's type in down, hit enter, left, hit enter, right, hit enter, and jump, hit enter. So for these custom actions, let's assign a keyboard key for each of them. The default move keys for the UI actions is up, down, left, right, arrows, which I actually don't like. WASD I think is preferable in most cases. So let's click on the up event and press W on our keyboard to get the W key and hit OK. And now W is assigned to up action. So just do the same thing for the other ones. Down is going to be
Udah ada W buat up, kenapa ada jam lagi ya?
S. Left is going to be A. Hit OK. Right is going to be D. Okay, so now we have our standard WASD. And then for jump, we can also make that space. It's okay that this is the same key as UI accept or whatever the other action was, I think for now, since we're only really using these actions, so it shouldn't conflict, at least for right now. Okay, so in our script, we just need to give it the same action names. So for our jump, instead of UI accept, do jump as the string name. For import get access, I'm going to do left. And then for the get access, the right direction, we're going to do right here. So for this get access function, the first value is the negative direction, and the second value is the positive direction. So for horizontal movement, left is negative on the screen and right is positive on the screen. That's why it's left here and right here. And now I guess we can hit play and just test our new keys. So WASD for movement now, and then space for our jump. And so far, so good. Okay, so let's add a double jump to our character. So I'm going to have a separate jump velocity for our double jump. We might not want the double jump to be as strong as the first jump. We can, of course, use the same values, but I think it's better if we at least have the option of customizing it. So under jump velocity, I'm going to add at export var double underscore jump underscore velocity as a float, and we're going to set that to negative 100 by default. Hit Control S, and we should see the variable pops up in the inspector. So for handle jump, if input is jump just pressed jump, and the character's on the floor, then we can do our normal jump. But if the character's not on the floor, then we want to give the character the ability to do its double jump. So what I'm going to do is move this is on floor underneath the is jump just pressed. So let's change that first line to just if jump was pressed. And then secondary condition, if Control V pasting it in is on floor is true, then we're going to do the normal jump. I guess I could comment that. Normal jump from floor. Else, we'll check if a double jump has already occurred. So if not has double jumped. Okay. And then if that's the case, a double jump has not occurred, then we'll allow the character to do a double jump in air. So of course we're going to get an error right here because has double jumped is not a Boolean variable we've set up yet. So go up to the top and
Function basic process. Add the gravity if not is on floor. Velocity gravity plus kali delta. Handle jump if put is action just press jump. If is on floor, velocity jump velocity. Oh, as has double jump, terus kasih velocity-nya double jump velocity kayaknya.
And under here or so for gravity, let's do var has underscore double jumped. Going to declare this as a Boolean variable. And we're going to default this to false. So when the game starts, our character has not double jumped yet. And then we're going to come down here, else not has double jumped. Oh, okay. It's a GD script, so it's not else, it's actually elif right here. So else if, so if the character is not on the floor, we go to check our secondary condition, has double jump not occurred. And then we can do our double jump in there. So that's going to be velocity.y equals our double jump velocity. And then
Terus ada
after our
ininya
double
juga
jump
ya.
occurs, we of course want to set as double jumped equal to true. So as the code is written right now, our character would only ever be able to do one double jump during the game. So we need a condition where we set has double jumped equal to false, and that's going to be when our character is touching the ground. So up here we have if not is on floor, then we do velocity y, gravity times delta to basically move the character towards the floor. But let's do a else here, and we're going to say has
Gak pakai if.
double jumped equals false. So if the character is on the floor, the opposite of this condition, we come down here, has double jumped is false. So whenever the character touches the ground, it hasn't double jumped. Okay, so let's hit play and let's test out our double jump. Okay, so we have a character, WASD to move, space to jump once, and let's do a double jump. So space, space, and you can see on the second jump, our velocity gets set to -100. So with this setup, the character would be able to jump high with quick double jumps like jump, jump, or you can make the character float across the screen a little bit by jump and then delay a bit and then do your second jump for longer distance jumps. And you can, of course, tweak the settings about how you want that to occur. You could radically change the mechanics of the double jump as well by doing a plus double jump velocity, hitting play, and then doing jump, jump, which now you can see that it's going to add the velocity to the initial velocity of the first jump. So double tapping jump means you can jump much higher now, but if you do the floaty thing, like jump, jump, then you can see that the second added jump velocity kind of gets counteracted by the gravity acting on the character. So not quite as floaty as it was before. Up to you on how you want your character to do things. I'm just going to start by setting the velocity directly to the double jump velocity though. Okay, let's go out to the scene. As our character moves around, we're going to want to have the camera track the player. So currently there is no camera, so let's add a camera to our test level. I'll right click on test level, add child node, camera 2D, and we want this camera to point at the player. So the way you can do that is right click on player, add child node, and do transform as the search, and then you'll do a remote transform 2D. This node can basically tell another node, like a camera 2D, what to look at. So create, and then in remote path, assign this to the camera 2D. Now if we hit play, the camera is going to constantly follow wherever the player is on the screen. Now this is just instantly tracking the player wherever the player is. That might not look ideal. So one setting you can change on camera 2D is to go to drag and enable horizontal and maybe vertical drag as well. And this is going to mean that the character has to move a certain amount away from the center of the screen for the camera to start tracking it. So let's hit play and you'll see how this differs. So as I move around the center of the screen, there's no camera tracking. But if we go to the edge of the screen, our camera will follow the player there. So it sets up this little box where the camera doesn't move even if the player does. And since we have vertical enabled as well, maybe our jump isn't enough to have the character track, at least a single jump. But if we fall off the edge here, it'll definitely keep tracking our character. The other thing we might want is position smoothing. So if we enable position smoothing here, then it'll mean that when the camera moves, it's not going to instantly jump to the position of the player, but it's going to take a second to change its transform to the new location over time at this speed over here, 5 pixels per second by default. But if we hit play, you'll see that there's going to be a little bit of a graphical issue. So if we hit play and our character moves, you'll see that there's like a lot of jitter here. So what's happening right here is that our camera's updating, I think, more than the player, because our player only updates on physics process frames. So if we look at our player script, you'll see physics process here. If we click on camera, you'll see the process callback is set to idle. So we want the camera to update only whenever the character updates, so that the camera smoothing looks correct. So change this to physics. And now if we hit play and move our character around, you'll see that the smoothing actually works correctly. So wherever our character is, there's not going to be any of that jitter, which is exactly what we want. So basically now we have our camera set up. Okay, so now let's take our character and set up some animations so that when it's moving around the screen that, you know, it's more than just one static frame. So it is possible to animate using the normal sprite node and the H frames over here to separate your frames out and then choosing which frame you want it to play. But another tool we could use is an animated sprite 2D node. So I'm going to add a child node. We'll do animated sprite here. So let's open up the animation window over here. Sprite frames. I'm going to do new sprite frames. Let's open up sprite frames. Inside of this window, we're going to want to make the animation speed 10. So 10 frames per second. Every frame takes up 0.1 seconds. Let's take the default animation, double click it, and rename it to be idle. And then drag in the idle sheet over here. And then to bring the idle animation over to here, let's use add frames from sprite sheet, go to art, legacy, character, idle sheet, and now we need to separate our character frames. So for vertical, change that to 1, and that should basically be all we need to do to separate this animation. So hit select clear all frames to select all 4, add the frames in, and you can hit play now, and that's going to be our animation right there. Since we're using animated sprite node now, we can get rid of the regular old sprite node, so I'm going to delete that from our player scene. We can move the animated sprite above collision shape, so the collision shape still shows in front of the player. So that's going to be our idle animation. Let's add in another animation. So new animation, and we'll do run. I'll double click it, rename it run. Add frames from sprite sheet, go up, find run, select it here. We're going to have 8 for the horizontal and 1 for vertical. Select all frames, add frames. And like before, we take the FPS and set that to 10, hit play, and we have our run animation. So let's also add in the jump animations. So there's jump start and then there's jump end. So I think what the art pack creator was intended here is that when your Y velocity changes to negative, you start playing the end jump animation. So there's jump start for the initial jumping, jump end for landing on the ground, and there is the jump all sheet here. So this is going to be a little more complicated because you need to play the right part of the jump at the right points in time when the character is getting into the air, or landing. So let's add a new animation. I'll call this one jump. And then let's try adding in the frames. I'll go to the all sheet for start here. So I'll start by doing
Banyaknya.
the jump start sheet, and let's divide this into 4 frames. So vertical 1, select all frames, add frames, and we can rename this to be jump start. So a transition start into jump normal and then jump end when the character lands. So let's add a new animation. This is going to be
Jump
jump
down,
air, add
jump air.
animation, jump end. Make sure all of these are 10 FPS. So I'm going to increase them all to 10. So for jump end, let's add the frames of animation from the jump end folder. Click on this, open. So this is 3 horizontal, 1 vertical, select all frames, add frames. And then jump air is going to be everything in between. And we can grab those from the jump all sheet. I guess for whatever reason, they're not right now in the normal jump folder, but that's okay. Let's go up, jump all. So we got this sheet. So we want to get rid of the first 4 and the last 3. I think this might take a little troubleshooting, but let's kind of go with that. So 12 horizontal, 1 vertical isn't quite right. How many frames actually in here? 5, looks like about 15. So let's keep adding until they're sliced correctly. Okay, yep. And now we can grab these.
Oh,
Okay,
kisah kini.
add frames, and let's hit play and test that. Yeah, I mean, that'll kind of work, but it's not exactly like an air float. So this would kind of work, but it's not exactly like a loop. So actually, I think I'm going to remove the jump air, and we're just going to add those frames to jump start. So jump start, let's add the frames from the jump all sheet. So 15 and then 1 for vertical. And we want to get these extra frames here. So the last 3 are just going to be when it lands. Okay, so right now, this is our jump. Okay, that should do all right. And then when we land, we have the last 3. So if we go through our animations, you'll see that the character isn't exactly positioned correctly for each of them, because some of the animation frames are a little bit separate from each other. So what you can actually do is change offset centered to off. So now when we look at where our character stands on each of them, it'll be in the correct spot. But this also means we need to offset the transform position and make sure that that's centered up here at 0, 0 again. So let's take the position. I'll try -32 and then -32 for the Y. And I think that should be okay. If we hit play and kind of test that. Okay. Seems roughly correct. So let's go to the idle animation, and I'm going to hit autoplay on load here so that when we hit play, it's going to be automatically playing the idle animation. So now we're going to need some logic to change between our animations. There's a few ways you can do it inside of Godot. One way, which I think we're going to do for this setup, is to just code it inside of our player script. If we click on animated sprite and we look at node up in the top right, we can see that there are these signal callbacks we can use, like animation finished. So when animated sprite is done playing an animation, we can basically react to the animation finishing and change that to a new animation. So for instance, if our jump end animation finishes after our character lands on the ground, then we can change to idle or run. And everything else would probably just be when we hit jump, we play jump start. If our character's moving, then we do run, and otherwise we do idle. So let's give this a shot. Let's jump into the player script. And the first thing we're going to need to do here is get reference to our animated sprite node, since that's where we're changing the animations. So let's do, underneath the export, say @onReady var animated sprite, and this will be a animated sprite 2D. We're going to set this equal to $ animated sprite 2D. So this is going to get the node with this name from our scene hierarchy. So it's going to look for animated sprite 2D from the list of nodes under player, and it's going to reference that inside of this script. So this will be ready at the function _ready function of a 2D node. But basically anytime after that, like physics process, it's going to be usable. So let's set up a function at the bottom of our script, and I'm going to call this update animation. Okay, so I only wanted to automatically update the animation if, let's say, there's no animation lock to our character. So if we had already started the jump animation, we don't want it to switch back to idle or run. So let's go to the top up here, and I'm going to add a animation _locked variable, which will be a Boolean, and I'll default that to false. So down here in update animation, if not animation locked, so if the animation's not locked, then we can update to either idle or run animation. So how we decide whether we want it to do idle or run, we could do something like if the direction is not equal to 0. So our direction is only in physics process right now, but we can actually pull this out so we can use it elsewhere. So let's do var direction, which is a vector2, and that'll be vector2.0 by default. So let's set the direction here inside of our physics update. Okay, so by removing the var in front of that, now we're updating the direction variable for our entire script, and we can use direction anywhere we want. So let's come down here. So if the direction does not equal to vector2.0, then we're going to make the animated sprite run. So animated sprite dot play, and I think this is going to need an animation name, so we'll do run. So when the condition isn't met, that means the direction is actually 0. So the character isn't trying to move, so we should make the animated sprite dot play idle. So let's see. A float cannot be assigned to a type of vector2. So the reason it's doing this is because this is actually getting a float up here. So instead of import.getAxis, I'm going to change that to get vector. So we're still going to have left, right for the x, but we're also going to do up, down, and remember the quotations there, for the y part of the vector. So this is our x left and right, and this is our up, down vector. Okay, so since we're dealing with a vector, not a float, down here we need to be direction.x is what we're going to pull for the velocity x. And then down here, we only care about direction x as well. So we're still getting the input direction, but we're not actually using this part. And then down here, we want it to be if direction x does not equal 0. Okay, and that should clear up all the errors. So basically, in a nutshell, our direction variable is a vector 2. It has a x input and a y input. We're not using the y input because W and S aren't controlling our jumps. It's the spacebar that is. But we still get that. We're storing it in the vector. But when it comes to whether our character runs or not, we're going to check only the x component to see if it should be playing run or if it should be playing idle. And when we update the x velocity, that's also only based on our x input. Okay, so now we can hit play and test that out. So I'm going to press D on the keyboard and A on the keyboard, and we can see our character is actually not running yet. So let's see. Oh, of course, that's because we're never calling update animation. So let's put that somewhere. I think down here should be fine. Update animation right before move and slide, or after move and slide should be fine. Actually, after might make more sense. I don't know, maybe collisions would at some point come into play when determining what animation we're playing. So let's hit play. And now if we press A and D on our keyboard, we can switch between idle and run animation. So whenever we're pressing the key, we run, and otherwise we're doing the idle animation. Okay, now we have another minor issue, which is that our character can't face the left direction. So we're going to need to flip the sprite in order to do that. So if we look at animated sprite, the inspector, there's a convenient variable here, flip x. So basically, whenever the character is trying to move to the left, we'll have it also face the left. But for right now, I don't want the animation lock to also lock in the direction facing. So we'll have a separate function underneath where we call on update animation, and we'll do update facing direction. So let's write that function, update facing direction, and we'll say if direction.x is greater than 0, then animated sprite dot flip h is going to be false. Else, or really else if the direction dot x is less than 0, then we're going to take animated sprite dot flip h, and we're going to set that to true. Now, we don't flip it when the direction is nothing, because that's when we have no input on the x-axis, and we don't want to flip the sprite when our character's just idling. So we only flip it when we either change our direction to the right direction or to the left direction. So now if we hit play, we should see that update correctly. So D for facing the right, and then A will make us run in the left direction. So pretty much as simple as that. And because of how we set it up, we can also flip our direction in the mid-air jump. Okay, so now we need to play the jump animation when we press the jump key. So let's go up here to where we do a normal jump from the floor. I'm actually going to change this bit here to, I'll call it jump as a function. And we'll take this y velocity part and we'll move it into that jump function. So let's go down here, function jump. So we'll paste in the velocity change, but we're also going to lock the animation. So lock animation, it's going to be set to true. And let's do that right after we change the animated sprite animation that it's playing. So animated sprite dot play, and we're going to play jump start. And as things are right now, it'll never return the animation to
Halo Kak Iron, thank you for
idle
coming.
or run. But let's show what that looks like. Let's hit play. I'm going to jump. So we get that jump animation, and it's looping, which it probably shouldn't be doing. But it also, when we hit the ground, it doesn't return to idle or run. So let's go to the animated sprite 2D view and open up sprite frames. So jump start, we want to turn off looping here. So take animation looping and turn that off. Animation end should also be turned off. Okay, so we want to change to jump end basically when our character hits the ground. So let's set that up. So in our script, let's keep track of if we were in the air, and then when we switch to the ground, that's whenever we're going to play the jump end animation. Whether we pressed jump or if we were just falling, we want the character to land basically. So let's have another variable set up. So was in air as a boolean, and we'll default that to false. So if not is on floor, then we're going to take is on air and set it to true. So if not is on floor, then we're going to say that we're in the air, but else if we are on the floor. So if was in air is set to true, then we're going to land. So let's set up a function for landing down here at the bottom, kind of like jump. So function land. And let's see here. So we're going to do animated sprite dot play jump end. And I think that's pretty much it. So let's jump and see if that actually occurs. So I'm gonna click over here to the left of this line and see if the land function actually runs. I'll hit play. Oh, well, there we go. Playing jump end animation. So I guess we'll just restart the game again and just see if that actually plays. It did not. I might have the name wrong for the animation. So let's click on animation sprite, jump end here, play it on our character. It's 3 frames. Okay, I'll hit play one more time. Okay, right, because we gotta lock the animation. So, so animation locked equals true. We can hit play. Okay, and there we get our little landing animation to occur. Okay, now to keep it from being stuck in that state, let's use animated sprite, go to node, animation finished, double click here, connect it to the player script, connect here. So on animated sprite, 2D animation finished. Let's check if the animation was jump end, and if so, then we release the animation lock. So if animated sprite dot animation equals, and then we'll do jump end, then we'll release the animation lock. That's false. Okay, and I'll hit play here, and we'll see if that occurs. Okay, hit play. And after we check for was in air, we should also be setting was in air to false to make sure that it doesn't keep showing was in air is true. Okay, let's hit play, and we can see, okay, our land plays once. Okay, there we go. So we hit space, we get our jump, we land, and our character ends up on the ground. I guess the more complicated you would get, the more it would make sense for there to be kind of like a state machine for your character. But on our landing, we can still move and kind of slide across the ground. So a quick way of just checking that, where we don't want to be able to slide while we're landing, is that we could go to, let's say, our if direction velocity x thing, and we'll check and the animation sprite dot animation does not equal, and we'll say here, what was it called? Jump end. So basically, like right here, except reversing it for not equals. Okay, and that's animated sprite. So over here for the direction, we want to make sure that it's not in the jump end animation where the character is landing. So let's grab this bit and reverse it. So if there's a direction input and the character animation is not equal to jump end, and we need to add something else for the direction now. So I'm going to do is if direction direction.x if direction x does not equal to 0. Okay, so basically the x direction needs to be something here, and the animated sprite should not be in the jump end animation. Then we can move the player.
Oh, alhamdulillah. Jujur kalau misalkan ngeliat beginian itu aku rasa di pertengahan sih. Di pertengahan itu selalu bayang-bayang sendiri apa yang bakal aku lakuin. Oke, ini videonya bagus. Ya lumayan, bener lumayan saya. Kepikiran. Wah, oke. Ya mungkin segini dulu untuk live streamku pada sore hari ini. Kayak lagi pengen jalan-jalan olahraga gitu. Semoga aja nggak hujan atau terlalu panas. Kalau misalkan aku ada salah kata atau perbuatan, aku mohon maaf. Thank you for coming ke planet otaku. Ya, mata atau ini. Nonton nih. Bye bye.